Hi students, welcome to Talanta chemistry class. Today is the day 13th of our 50 days consecutive crash course online program that is being conducted entirely free of cost for the four subjects, namely physics, chemistry, and zoology, botany. So in day 13th, we are going to solve some 12, 13 very important type of MCQs from the chapter, organic chemistry chapter of class 12, alcohol, phenol, and ether. So here we go. The first question is, what reagents are needed to accomplish the following transformations? This is the transformation. At first, we have to focus on the reactant and the product. See, in the reactant, the 1 degree alcohol group is present, CH2OH, and in the product, that 1 degree alcohol is being oxidized to corresponding aldehyde, CHO. But the other things like these two ethereal group, they are remaining intact. These above the plane methyl is remaining intact. The benzene ring is remaining intact. The all those stuffs are remaining intact. Only CH2OH is being transformed to CHO. This is a selective oxidation sort of reaction. It's a very common reaction. You all know. Is a PCC is used. That means CrO3, HCl, and pyridine. So option C is the correct answer. Next, we will move to question 2. So this is a 1 degree alcohols, cyclic stuff is there that is being treated with H plus and heat, and A is being formed. Well, if you have practiced already in appreciable amount of problems, MCQ problems, then when you will look to this type of problem, you can easily understand that at first what will happen. So there are five carbon atoms in the ring and one CH2OH is there. So at first, when H plus will be given, then OH2 plus will be formed by donating the lone pair over here, and then CH2 plus carbocation will be formed. Then ring expansion will happen, and ring expansion, 5 membered ring will be converted to the 6 membered ring, and of course 6 membered ring is a very stable stuff. The 6 membered ring will become when it will gain aromaticity by gaining the structure of benzene nucleus. So B option is correct. If you have already practiced appreciable amount of MCQs, I have already told, then you can, after seeing the problem within flick of second, you can already guess the answer. You don't have to touch pen and paper for solving this problem, provided you have practiced appreciable amount of MCQs related to this type of basic mechanism stuff, right? Here I'm going to show the mechanism. How does it happen? So this was the starting material, CH2OH, that is being treated with H plus. Lone pair of oxygen is donated to H plus, and this OH2 plus ion is formed. OH2 plus is an excellent leaving group. Then it leaves. This will be CH2OH plus, not OH plus. CH2OH2 plus. Then OH2 water is released as leaving group, CH2 plus. This 1 degree carbocation is formed. Then this ring expands. So we'll get a 6-membered ring. As this bond is being broken from here, so here shortage of electron will be caused. So that's why we are getting a carbocation over here. And this is non-aromatic stuff. Next, it will try to gain aromaticity to be stabilized. So by deprotonation in the final step, benzene will be formed. So this is the mechanism. Hope you have understood this. Next, we'll move to problem 3. Yes. Which of the following alcohols is least reactive towards acid catalyzed dehydration? So acid catalyzed dehydration, it basically proceeds via carbocation formation. At first, in the first step, the OH will react with H plus, which will be liberated from the acid to form OH2 plus, like the previous mechanism. These same thing will happen over there, the same mechanism. This carbocation will be formed, and then accordingly dehydration take place by deprotonation, whatever uh, you have already seen here. So here what we have to consider, the stability of the corresponding carbocation, that because it goes through carbocation formation. So here we will get, at this carbon plus will be generated. So here we'll get 2-degree carbocation, here we'll get 1-degree carbocation, here we'll get 3-degree, here 2-degree, but this is allylic 2-degree, so highly stable stuff, right? So most unstable carbocation will be formed in compound B. So it will be, of course, least reactive towards acid catalyzed dehydration, because acid catalyzed dehydration reaction, the carbocation formation step is considered to be the rate determining step. So option B is the correct answer. We will move to question 4. So this is Spiro sort of compound that is being again treated with H plus in presence of water. In the first step, that is the rhythm, this OH plus will take this H plus, and then what you have to guess, this 5-membered ring, if it gets chance, it will be expanded to 6-membered. So, and this will try to get aromaticity. So let's check the mechanism. How does it happen? So this is the starting material is being treated with H plus. The lone pair of oxygen is taking the H plus from the medium. So OH2 plus. Next, this thing happens. So this water has been removed, no group is there, this pi bond has been shifted over here, this double bond is remaining intact. So pi bond, double bond remaining intact. 5-membered ring was there here, and now this carbon is expanded to this carbon, is being attached to this carbon, and as a whole the system is being expanded. The ring, now 5 carbon was there, now this carbon is being incorporated in the ring, then that's why 6 carbon atom will be there. So 6-membered ring will be formed. What is the basic driving force behind this? Because 6-membered ring is highly stable, its thermodynamic stability is quite high than the 5-membered ring. So this stability gaining is the driving force behind this step, right? So what happens over here, so we have to draw it this way. This 6-membered ring, and as from this carbon atom the bond is being broken, so here shortage of electron, and results, as a result we are getting a plus charge over here. And the final step, what happens, a deprotonation happens to gain the aromaticity to stabilize the system. So this is the final product. So let's check the option. Option A is the correct answer. Next, we'll move to question 5. Well, the same thing, the carbocation formation will happen here. Here, a migration will happen also. In the first step, we'll get this carbocation, and then this methyl shifting happens. Pi bond has been shifted over here. This pi bond is remaining intact, and in these carbon atom, due to the breaking of the sigma bond, lacking of electron happens as a whole. Here plus charge is generated, and in the final step what will happen, it will again try to gain stability by gaining aromaticity. So in the final step, so we'll have aromaticity will be gained by deprotonation. This is the mechanism. So two methyls will be present, two methyl groups will be present in the benzene ring in 1 2 position. So option B is the correct answer. Next, question 6. In which of the following reaction pair of diastereomers will be formed? So again, we have to find out the product. When you know this is also treated with H plus and heat. So here, if we write down the mechanism by doing the 1 to hydride shift and all those things, you will get this product you will get, and no, here will not get cis trans is not possible. It is not possible here. No. This is one is methyl, another one was ethyl. So this is. So this product will be formed here, and here E and Z, two isomers will get EZ isomer. The EZ isomer of same compound are diastereomers to each other. Similarly, cis and trans isomer of same compound are diastereomers to each other. As here we'll get two isomers E and Z of these compound. So here diastereomer will be formed. Option A is the correct answer. Next, we will move to question 7. Which of the following alcohols dehydrates with the fastest rate? Again, the same question, same sort of, because these type of question often comes. So that's why we have stressed on this particular type of the mechanism, the carbocation formation. We always have to remember in this type of dehydration reaction, the carbocation formation step is a rate determining step. So the most stable carbocation, where the most stable carbocation is formed, there the reaction will become fastest, and similarly where the least stable carbocation is formed, that reaction becomes slowest or least favorable. So here they ask that which reaction, which molecule undergoes fastest reaction. Well, so the most stable carbocation will get here in C, because we'll get a 3-degree carbocation over here. So option C is the correct answer. Next question 8. These cyclic alcohol that is being treated with H2SO4. So in the first step, dehydration takes place. So we'll get cyclohexene. Then it is being treated with NBS. NBS, helps to monobrominate at benzylic and allylic carbon atom. So here monobromination takes place in allylic carbon, then LiAlD4, Br will be substituted by deuterium. So this D. So option C is the correct answer. Next question 9. What is the major product of the following reaction? These paramethyl phenol is being treated with bromine in presence of FeBr3. So what will be the major product? Here FeBr3 acts as Lewis acid catalyst. Their aromatic electrophilic substitution takes place. OH group has plus R effect, whereas methyl exerts plus I. As OH has plus R, so with respect to OH group, the orientation of the Br atom will be determined, as it is more electron donating. So with respect to OH is the orthopara directing group. So with respect to OH, Br will enter at ortho position in one compound. In another compound it will enter at para position, but in this compound the para position of OH, the para position, this one with respect to OH group, has already been blocked by a methyl group. So para is blocked, of course, so one position is open, the ortho position with respect to OH group. So either at this carbon or this carbon, Br will enter. So option E is the correct answer. Next question 10. Compare the rate of acid catalyst dehydration. The same thing, we have to again focus on the carbocation, corresponding carbocation from the carbon which contains the OH group. The OH will be released, and at that carbon atom the carbocation will be formed. So here what we'll get the carbon, the benzene ring, the carbon present in the benzene ring is containing the plus charge. That means is a vinylic carbocation, highly unstable. Here we'll get a 2-degree benzylic carbocation. This is highly stable, and here we'll get normal 2-degree carbocation. So most stable carbocation is this one, benzylic 2-degree. So 2 will be the fastest, then 3 normal 2-degree, and then vinylic highly unstable carbocation. So rate of dehydration of the first compound will be the lowest. So option B is the correct answer. Next, we'll move to question 11. Phenol is being treated with sulfuric acid at 110 degrees Celsius. We are getting P as major product, and then P is being treated with NaOH fusion, and then it is being protonated by H plus. We are getting Q. Product Q is so when phenol is being treated with sulfuric acid at 110 degrees Celsius, as major product we will get is SO3H group will be entered with respect to OH group at ortho and para position, because OH group is ortho para directing. So in this step we'll get two products, this one and this one. This becomes major product. This is P, and when it is being treated with NaOH fusion and H plus, then what will happen? NaOH fused will get this stuff, ONA sodium phenoxide, and then after protonation ONA will be converted to OH once more. So this will be the product. Q, option C is the correct answer. We'll move to question 12. This compound is being treated with KOH, chloroform and H3O plus. What will be the major product? Well, here this is basically Friedel-Crafts. Uh, what's the name? Reaction, Riemann reaction. So what happens here? CHO group will be inserted with respect to at ortho and para position with respect to this OH group. So here ortho is blocked. Sorry, major product they have asked. So here ortho is blocked. So at para position CHO group will enter. So C will be the correct answer. 12C. This is basically Riemann reaction. Next question 13. This reaction, this is again Riemann reaction. We are getting this product. In the given reaction, the intermediate species is, it basically, goes through dichlorocarbon intermediate formation, Riemann reaction, carbylamine reaction. These reactions go through dichlorocarbon CCl2 double dot, these intermediate formation. So option B is the correct answer. Next, HIXS, this compound is being treated with. So what will happen? So in the first step, the firstly what we have to understand, these OH group, as this lone pair is involved in resonance with the benzene ring, so this carbon oxygen bond is getting double bond character. That's why this bond is stronger. It will not cleave and react with this H plus. So this OH will remain intact. This is the first thing. This OH, this lone pair is available. This is not, involved in resonance with the benzene nucleus. So in the first step, it will accept the H plus. What will happen in the first step? So in the first step, we will get these highly stable benzylic carbocation will get here. Next, I minus will attack this CH2 plus to form CH2I OH. So option D is the correct answer. So that's all for today. Signing off for now. See you tomorrow. Keep sharing Talanta. Keep sharing good words about Talanta. Keep supporting us. Thanks for watching.